Welcome back to the solutions for 6-step examination paper. We are looking into the past year questions. We had already done the first part in the previous video. Now we will be looking into the second part of this question. The second part has two quadratic equations. They will be solved similarly. We just have to go through the calculations. So for second part A, we will assume y equal to root over x plus 2. Right? Again, take y greater than equals to 0. Therefore, we have y square equal to x plus 2, right? Implies x equal to y square minus 2. Now we will have to use this replacement in this equation. So replacing, we have just put the values of x. So we have y square minus 2 plus 10y, right? Because 10 was the coefficient here, minus 22 equal to 0. Alright, so this gives us y square plus 10y minus 24 equal to 0. Now this we can transfer into middle term, right? So factorizing, this will be y square plus 12y minus 2y minus 24 equal to 0, which would give us y plus 12 into y minus 2 equal to 0. Now as y greater than equals to 0, again reject the negative solution, we have y equal to 2 as our solution, right? If we have y equal to 2 as our solution, then you can just put the values in x and check if that's a solution, right? So x will be equal to y square minus 2 equal to 2 square minus 2 equal to 2, right? Therefore x equal to 2 is the only solution. Alright, you can just put the values here and verify. See, root over of 2 plus 2, that is 4. That means root 4 is 2, right? So 2 plus 10 into 2, 22, minus 22 is 0. So we don't even need to do some calculations stepwise to verify it. You can just mentally do the additions and subtractions and get it done with. Alright. Similarly, for the second subpart of the second part, we have x square minus 4x plus this quadratic, right? So we can assume that to be y. So assume y equal to root over of this big term 2x square minus 8x minus 3. 2x square minus 8x minus 3. Again, take y greater than equals to 0. So therefore we have y square equal to 2x square minus 8x minus 3, right? Or I can write 2x square equal to y square plus 8x plus 3. Now I'm not taking the exact value of x square, because instead of that I can multiply this one by 2 and replace 2x square, right? So I wouldn't have to do a lot of calculations. So replacing, wait, instead of that we'll write the original equation. That is x square minus 4x plus root over of 2x square minus 8x minus 3. Alright, now here instead of replacing x square, I will have 2x square minus 8x equal to y square plus 3. Alright, just a simple change so that the substitution becomes easier. Equal to 0, right? So this is a different part. Alright, so multiplying by 2, we have 2x square minus 8x plus 2 into root over of 2x square minus 8x minus 3 equal to 0. We did nothing apart from multiplying this entire equation by 2. That is valid, right? We can multiply the left and right side of an equation by the same number or the constant, and it would not change the value of the equation, right? That can easily be done. So now we replace this there. So once we do that replacement, replacing, we have y square plus 3 plus 2y equals to 0, right? Wait, we had one more term here, right, that I missed. Yeah, it was minus 9, right? That's why I was thinking what happened. So this is minus 9 here. Just adjust the terms here. Minus 9 equal to 0. This will be minus 18 equal to 0. So here we will just have one more term, minus 18 equal to 0. That should give us y square plus 2y minus 15 equal to 0. Again, middle term. So factorizing, we have, this is 5 minus 3, right? So y square plus 5y minus 3y minus 15 equal to 0, which would imply y plus 5 into y minus 3 equal to 0. Again, since y is positive, as y greater than equals to 0, we select y equal to 3 as our solution. So now we have to solve another quadratic, right? Because we had assumed y equal to root over of 2x square minus 8x minus 3, and we get y equals to 3. So I can put it in this equation, and I will have, let me name this equation A. So putting y equal to 3 in A, we have 2x square minus 8x equal to 3 square plus 3, right? So 3 square is 9 plus 3, 12. So that means x square minus 4x equal to 6, or x square minus 4x minus 6 equal to 0. So this is the equation we obtain, right? So once we obtain this equation in x, now there are no restrictions over x, right? Like y had a restriction that it had to be greater than 0. Here there is no restriction. So can we factorize it? I don't think so. 6 can all be broken into 6 into 1, which would give us 5 in the middle. That is not the case. Or 2 into 3, which would give us plus 1 or minus 1. So this cannot be factorized. Therefore apply the quadratic formula. Therefore x will be equal to minus b. So 4 plus minus root over of b square, 16 minus 4 into 1 into minus 6 by 2. So that would give us 4 plus minus 16 plus 24 root 40. So 40 is 4 into 10, right? So if I divide by 2, I will get 2 plus minus root 10. How did I get this? So 40 was 4 into 10. So it will be 4 plus minus 2 root 10 divided by 2. One of the 2's will cancel. So I'll have two solutions of x. X equal to 2 plus minus root 10. Okay. I hope this is clear. Now the sums were quite easy. You just had to do the calculations carefully. Okay. The initial point of the sum was to use the substitutions in a way such that the linear and fractional power of x's are converted into quadratics and linears, so that you get a quadratic equation and solve it. Alright, if this hint was not given, these problems might have been a tad more difficult, but since all the necessary information was already given in the question, you just had to follow the instructions and then solve the questions logically. Okay, now I hope you have understood this. If you have any queries, please make sure to mention them down in the comment section. Our team will look into it and we'll get back to you. Okay, I'll see you for the next PYQ video, and in that we will discuss a different question. Okay.